Control structures sequence. A program is an algorithm written in a specific language that is understood by and runs on a computer. Some examples are software programs, websites, and video games. Every algorithm contains some combination of three control structures. A control structure is something that determines the order that statements are executed and/or the direction to go. Clarity and readability are important considerations when expressing an algorithm in a programming language. A code statement is a part of program code that expresses an action to be carried out. The three control structures are below. Sequence, which is a series of precise statements. Selection, where the algorithm can select one of two paths. And repetition or iteration, where an algorithm can repeat a sequence. They are the basic building blocks of algorithms. We will begin to use flowcharts to help us understand these control structures and also draft our programs. In order to function properly, computers need precise sets of instructions that can only be interpreted one way. They need algorithms. The more complex algorithms become, the more programmers need to organize the flow of them so that the simple binary choices are recognizable to them when writing the actual code. Flowcharts are diagrammatic representations of algorithms, processes, or workflow. They use various boxes, connected with arrows to show order, to visually represent the steps that the algorithm will take prior to actually writing it. Flowcharts are just one example of how computer programmers plan programs before writing them. The first control structure we will look at is sequence. We often give instructions using sequence as it shows procedures in a step-by-step format. The flowchart below uses arrows to show the order in which each step must occur. The oval represents the start or end of the algorithm, and each rectangle represents a step or process. The code we wrote in the first unit each had a sequence. For example, remember this one? How could you represent this sequence in a flowchart? Did you get something like this? It's okay if you used all rectangles, but do you notice the parallelograms in the solution? Here, here, and here. Flowcharts use different shapes to represent different but universal meanings. The parallelograms represent input or output, in this case, output, print statements. The chart below describes the most common flowchart shapes, including those that will be seen on the AP exam. We will use these more throughout the course. An oval represents the start or end of the algorithm. A rectangle represents one or more steps or processes. A diamond represents a conditional or decision step, true or false, yes or no, etc. And a parallelogram represents input or output. Sometimes it just displays a message.